So next I made a start on the right wing. I got the VTX mounted in its position there. Sorry for the glare, with the VTX mounted in its position out on the wing. The underside of the wing being completed now, as you can see. The servos or servo I should say fitted for the aileron. The other servo wire you see is for the elevator, which will plug into the rear on that connector there. That's a connector I've used for that. When the tail goes in, it'll just plug into that 3-pin plug. The cables obviously terminated off the 3 cables you see there for the VTX, for the aileron servo and for the elevator servo. The servo horns have been fitted, the servo push rod linkages all fitted up now, and that is the LC filter for the VTX. Also mounted out on the wing as close to the VTX so I can get it to stop any interference getting through to the VTX. I then went ahead and joined the wing halves, as I'm going to be using a one-piece wing for this model, and that's the wing there in its entirety. The upper side of that wing complete. See if we can turn this over. And the underside of that wing now taped. Everything as it should be. And the connector, which will plug into my electronics stroke avionics board on the end of all the cables situated there in the center of the wing. So after completing the wing, the next step for me was to make a start on the electronic stroke avionics board that sits inside the fuselage on the Skyhunter, and this is what's on the screen here now in front of us. The heart of the whole system's an APM 2.8 flight controller. Trying to keep as steady as I'm doing this, which you can see in the shot there now. That's the autopilot, of course. The receiver above it is an Open LRS receiver that was programmed by myself with Open LRS NG and set up the way that I want it. To the right of that you can just see there's a minim or a micro or a mini, I believe, minim OSD unit that puts all the information onto the OSD telemetry screen back to me at the ground station. That in the shot now is a Wi-Fi telemetry unit that I can use to connect to this plane wirelessly from my mobile phone, my tablet, my PC for uploading missions, changing parameters, whatever I want to do. Below that is a 20 amp 5 volt BC, which is powering just about everything on the aircraft. The connector at the rear is the connector for the wing to plug into. On the front panel of the unit, I made a breakout panel on the front there that presents nicely inside the aircraft when the canopy is off. To the left is the on-off switch. That's for turning on or off the Wi-Fi telemetry unit because I don't like that on in the air when I'm flying. I only use it on the ground. The next is the breakout connector to the Canopy that takes all the control for the pan and tilt, the OSD feed camera, and also the DVR recording camera. And next to that is a mini USB connector which is attached into the APM, so I can actually connect to this APM two ways, wirelessly or wired. And the cable off to the battery connector. As you can see, 3 connectors on there, so I could fly 3 batteries on this aircraft. Underneath is the power module for the APM, which reads the current and the voltage, which again comes back to me on the telemetry on my headset on the ground. So that's it. That's the electronics avionics board. Quite a bit of wiring, everything's working, and I'm very pleased that it's finished. As the ESC is going to be installed inside the fuselage, I thought it prudent to increase the heatsink on it a little bit for mounting and cooling. So I cut the heatsink out of its heat shrink jacket like I normally do. I 3D printed a base mount for it there, and added a new piece of heatsink on the top to the existing heatsink in the ESC, just to let the thing breathe a little bit better. Whole thing's held together with a single tie wrap. That should make things considerably cooler on the ESC inside the fuselage. Here are a couple of shots of the ESC in its position in the fuselage half prior to the halves being joined. So after mounting the ESC inside half of the fuselage, everything was kind of ready to go together. So the 2 fuselage halves have been joined. The avionics board fitted in the inside there. The motor has now been mounted with currently an 11.7 prop, but I've got 12.6 and 11.5 to play with. And the battery has been, the CG has been sorted out. Battery's in the front there. Into the fuselage, looks like that, with the breakout panel for the APM and all the information that I need on the front panel. The GPS receiver sitting nicely on the top there, the Radiolink SC100. And as I'm going to be using wing bands, not the screws, carbon spars have been fitted for the wing bands, which I've made myself to accommodate holding the wing on. And I think that's just about it for the fuselage. So after the avionics board was complete, the next thing I turned my attention to was the canopy. On the Skyhunter 1800, the canopy comes in 2 parts, so I made it one solid piece. 3D printed an air scoop that I took into the top there. And the payload for the aircraft, obviously, the pan and tilt, 360 pan and tilt. The USD camera is the Foxia Monster Micro Pro. And my recording camera is the Firefly Q6. The side of the canopy is like that. That's the wiring. LC filter and the feed to the USD camera, and a ferrite ring toroid, and the output from the camera off to that D connector, which interfaces with the one on the front of the electronics board. Those 3D printed clips you see on the front I changed the orientation of the canopy as it comes out of the box. This canopy locks in at the rear and then you lock the front down. I've changed that. So this canopy will actually lock in from the front using those, and then hasps at the top to lock it down. Makes more sense. The airflow obviously coming that way, front's constantly locked in, so the canopy can't lift. So I'm going to do a walk around of the airframe. It's nearly completed virtually. There's just a few things to finish off inside the canopy, and I'm quite pleased with the way everything's come together. We'll start at the back actually. The whole build gets a lot of 3D printed parts, tail and boom, Emax 12 gram metal gear servos all around with custom made servo arms on each of them. Camera position on the tail for the Mobius, they can set to looking forward, looking back, and strengthening pieces in the corners and carbon in the vertical stabilizers just to stiffen those a little bit too. Coming around this side, motor is the Sunny Sky X2820 1100 kV I believe. On there's a 11x7 prop currently, but I've got different sizes of props to play with. I've decided to attach the wings to the fuselage with wing bands that I make myself. My wife gets me 1-inch elastic from a local haberdasher's, and they work out pretty good for that. VTX out on the right wing, and dipole, UHF dipole out on the left wing. Coming up the front we have the Radiolink SE100 GPS receiver, which works exceptionally well, and 360 pan and tilt. If we can just show you how that works if I can. Sorry, things are a little bit jerky here, but I'm walking around with a plaster cast on my leg at the moment. DVR camera is a Foxia Monster Micro 1200 TV line. Low latency and quite low light as well too, which is nice. And the recording camera is my trusty Firefly Q6. 3D printed out a cooling air scoop and put that in the top of the canopy, and also the nose skid to kind of give it a little bit of protection. Another camera mount under the wing for a Mobius, so 3 camera positions on this aircraft. The whole underside of the aircraft is black, which of course is the best colour to see against the sky. And 360 pan works pretty good. Along with, I don't know how I'm going to do this actually, along with tilt to give an all-round view, or as close to all round as I can possibly get. And that is really it. So UHF dipole out on that wing, obviously above and below the wing. And that is my Skyhunter 1800.